Hello, buddies. Welcome to the Distributed System Design session classes. And today we discuss the design concept of the Aurora. Aurora is a AWS service that's based on MySQL and PostgreSQL and a set of open source databases. And it's a part of the AWS service. And today we describe the architecture design. Since it's on top of the MySQL, it's quite natural to compare it with the MySQL. From MySQL, you see what happens when we send a request. Let's say an update request. It's a cluster. In the Aurora, we can set up 6 MySQL databases across 6 availability zones, and each is a replica of the data. When it comes a request, it goes to one of the availability zone, and we call it the primary instance. It saves the transaction requirement to the S3. And in the meantime, it gets the data from the disk, and later on, once it has the data, it has the update operation, and later on write the data inside of the disk. In the meantime, it sends the request to other mirror databases synchronously. We can send the request in parallel so that we do not have to wait for the other 5 replicas, just one by one. And once we get acknowledged that the update has finished in other databases, we can acknowledge the request that we've already finished the synchronization of all the data and is available in the 3 availability zones, and they are ready to read. But you see the bottleneck is the I/O. For whichever in the 6 availability zones, which is the slowest, the request time will be determined by the one that is the bottleneck. So the solution of the Aurora is to split all the services. It splits the top is the CPU. It makes all the transactions, and below it is the memory, and even below it is the storage. The storage is made up of the S3, which saves all the transaction logs. The other part is the disk, which is the snapshot of the current table. Instead of relying on the table for all the transaction control, it's called the log database, which means we do not send the current status of the database to another one. It's not like we compare them table by table, row by row, and if there is a discrepancy, then we overwrite the value in the replicas. Rather than that, we send the transaction synchronously to the replicas. The replicas will handle them, but is asynchronous means that the request coming to the primary instance do not have to wait for the asynchronous calls. It will return finished as long as the primary instance acknowledges it. The problem may be easy to witness is it do not guarantee the consistency of data across the availability zones. So it's solved like this. We know that whichever data we change, it's cached, right? It's in the memory. And the memory is a different service that's independent of the host. You can assume there's only one memory service. It's a single point. And the replicas are used for the storage replication only. For the memory cache, it can use the memcached or anything, but since first we don't care if it's replicated. If we lose, then we lose. We can still go to the disk to read it. We do not have to persist it. So we want to utilize this core feature of the cache. So if there is no change, we can assume that the data across the replicas are consistent. Then we can go to any disk to read it. And if there's a change, if there's an update, we do not go to the disk because there is already a record in the cache, right? So wherever it comes from, the request can always go to the cache to read the latest data rather than going to the disk. In this way, we guarantee the consistency of the data across different availability zones.